In match problem 4, now we want to find a definite integral, in this case evaluated from 1 to 2, of the natural log of 3x, and we want to interpret the result geometrically. So if this curve is the graph of f of x equals the natural log of 3x, then what we're saying is we want to find the area between x equals 1 and x equals 2 under the curve. So when we say interpret the results geometrically, we just mean explain this idea. What we're calculating is that area under the curve bounded between those two values for x. Now we do have a trick to this problem. We're trying to integrate from 1 to 2 the natural log of 3x dx. We only have one function, so this goes back to a problem that we looked at back at the very start of this module. Even though we don't normally write it, we could rewrite this as 1 times the natural log of 3x. So now we have two different functions, 1 and the natural log. And actually I'm just going to rewrite that in a different color so that we don't get confused with where we should be making substitutions for u and v. So we can add in that 1 times the natural log of 3x. So as I stated in one of the previous problems, anytime we have a natural log function, that should become u. Again, the reason being because we can't integrate the natural log function directly. We'd have to apply integration by parts, but that would just be overcomplicating things since that's what we're trying to integrate in the first place. And this means that dv is going to be 1 dx. So v is going to equal x, and du will equal 3 over 3x dx, or 3 over 3 here just cancels. So du equals 1 over x dx. So we need to plug this again into that formula for integration by parts. So this would become the natural log of 3x times x minus the integral from 1 to 2 of v, which is x, times du, which is 1 over x dx. So this is x times the natural log of 3x minus the integral from 1 to 2 of x over x is just going to be 1 dx. So this is x times the natural log of 3x minus the integral of 1 will be x evaluated from x equals 1 to x equals 2. So we get x times the natural log of 3x minus 2 minus 1, or x times the natural log of 3x Let me go back there. My apologies again, overlooking something. So when we say this, now we're evaluating this from x equals 1 to x equals 2. This entire expression, even though this portion was never integrated, it was just u times v, we need to plug x equals 2 and x equals 1 into this entire resulting function. And I was skipping ahead a little bit there. So what we want to do is evaluate 2 times the natural log of 3 times 2 is going to be 6 minus 2. So we want to take this minus now that entire expression evaluated at 1. So that'll be 1 times the natural log of 3 times 1, which is 3, minus 1. So again, distributing that negative through, we get negative natural log of 3 plus 1 is going to give us 2 times the natural log of 6 minus 2 minus the natural log of 3 plus 1, or approximately 1.4849.